Welcome back everyone. So let us understand the types of polynomials. Polynomials can be categorized on the basis of degree and terms. What is the degree of the polynomial and how many terms it has, right? I hope it is making sense to you. So let's understand what are the various types of polynomials on the basis of degree. On the basis of degree. Now, see, if you want to categorize polynomials on the basis of degree, then degree is what? Degree is something which is the highest value of the variable in a polynomial. I hope it is clear to you. So the highest value can be 0, can be 1, can be 2, can be 3, can be 4, and on the basis of those values only we have categorized the polynomial. So first one comes the obvious one, that is if the degree is 0. So where the degree is 0, they are known as constant polynomial. Constant polynomial. Now constant polynomial are somewhere whose degree is 0. And what are the terms which have degree 0? And they will be nothing but only the constant. For example, 1. 1 is, see, there is this x, but it has a degree 0, and that is why it is written as 1 only, right? For example, next one is, let's say 2, minus 3, under root 5. All of these terms have a degree of 0. There is also this one, that is pi, right? Pi is also a polynomial, is a constant polynomial, right? Now, moving forward, the second type of polynomial we have is linear polynomial. And as the name suggests, linear is what? Whose degree is 1, right? So degree is 1, then x will be my linear polynomial. So there is a general form of these linear polynomial, and that is ax plus b. If the expression in the form is, the polynomial is in the form of, this is what general form, ax plus b. So here this 3x plus 2 could be my example, right? What else can be my example? Under root 2 y plus 3, right? This could be one of the example. Next, see, if I put this, what these a and b are real numbers, right? This a and b are real numbers. So if a and b are real numbers, so this could be 3 by 2 z plus 0, and this is what? This will nothing but 3 by 2 z. I hope it is fine to you. These could be various examples of linear polynomial. Moving forward to next type, that is quadratic polynomial. Quadratic polynomial is what? Which have degree as 2. Degree should be 2, and in this case the general form will be ax square plus bx plus c. So let's see what could be the example of this one. First one is nothing but, let's say, 3x square plus 2x plus 1. This is a quadratic polynomial. Next is, let's say, 4x square plus 1. This is also a quadratic polynomial. Why? Because here the value of b is 0, right? Next is, let's say, root 3x square. This is also a quadratic polynomial. I hope it makes sense to you, right? Now, moving forward, we have cubic polynomial. And as you can obviously predict the cubic polynomial will have degree as 3 and its general form would be ax cube plus bx square plus cx plus d, right? And what would be its various examples? So its examples could be 3x cube plus 2x square plus 3x plus 1. This is one of the straightforward example of cubic polynomial. If I write under root 3x cube, this will also be a cubic polynomial. Why? Because here the value of b, c and d is 0. That we can take obviously. Now moving forward, last one we have is bi-quadratic. Bi-quadratic polynomial. So bi-quadratic polynomial is what? As you can predict, it will have a degree of 4 and its general value will be ax to the power 4 bx cube cx square dx plus e. I hope it is completely clear to you, right? And the various examples could be straightforward one. See, you just put the real values of a, b, c, d and e, and that's how you will be getting a bi-quadratic polynomial. So first example, this could be 3 by 2 x to the power 4 plus 1 by 2 x cube minus under root 2 x square. Now this is what? This is a bi-quadratic polynomial. Why? Because again we have taken the value of d and e as 0. So that's how we have classified various polynomials on the basis of degree. Let's understand them on the basis of terms as well. So now let's see on the basis of terms how we have classified the polynomials. And these types, see, as you can clearly observe or clearly anticipate, the bifurcation will be done of if there are one term, there are two terms, there are three terms, there are four terms, such like that, right? So that is how we will be classifying the polynomials on the basis of terms. Let's understand this bifurcation using some examples. Now, there are primarily there are four types there written over here. Firstly, I would like to proceed you on monomial. Monomial. In the table, it is the second one. Monomial, which consists of only one term, as you can see, 5 4b square minus 9 cube, right? These are what? These are nothing but only one terms are there. So this will be monomial. Next, binomial. So binomial is what? Consisting of two terms. As in the third row you can see, binomial will consist of only two terms. It doesn't matter what is the variable, what is the degree. Binomial will be like that only. Proceeding forward to trinomial. So trinomial will be what? Again you can anticipate trinomial will be of three variable. So x square minus 5x plus 6, this could be a trinomial. Obviously 5a to the power 4 minus 3a cube plus a, this also will be a trinomial, right? And last one will come, that is polynomial. So polynomial, as you can see, we have already understood the meaning of this word, that is, it is consisting of many terms. So many terms is what? That is, it could be of two terms, it could be of three terms, it could be of many terms, more than two terms, right? So monomial, binomial, trinomial, they all the types of polynomials only, right? And that's how we have classified the polynomials on the basis of degree and as well as on the basis of terms. I hope this is clear to you. See you in the next class with new concept. Thank you.